I am giving you 3 instances. 1. What is the square root of minus 49? 2. What is the solution to the quadratic equation x squared plus 16 equals 0? 3. If someone says to you, divide 10 into 2 parts, one of which multiplied into the other shall produce 40. In all these 3 cases, what is the common aspect that you can think of? Welcome to this video on the most eluded concept in the number system, but which only completed the entirety of our number system. It is the imaginary number. Okay, what were your answers to the 3 instances? Did you think it is impossible to solve or there is no solution? Say in this first question you might think, what? Square root of less than nothing. But we know we perform operations on negative numbers all the time. Well, hold on tight to know about square root of a negative number. In the second one, x squared equals minus 16, again, square root of a negative number. So at the outset, looks like no solution. In this third one, looks like it is impossible to solve this. Probably, these answers are as old as our imaginary number. Keeping a long story short, for over 2,000 years, we have had numbers which were conceivable that included greater than 0, that is, 1, 2, 3, and so on, which are known as natural numbers. This was what used for all counting purposes. Then came 0, lesser than 0. Interestingly, when lesser than 0 numbers, that is, negative numbers had to be introduced, people were so skeptic. But when it got its way in real-life applications like borrowing money, sharing resources, people started accepting it. As civilizations were evolving, people needed more numbers to answer questions like distribution of food, lands, water across regions, and for money transactions during which fractions came in, that is numbers in between 1 and 2 and 3, filling the gaps in this number line, that is, when any 2 integers are written as ratio, we have rational numbers and then square root of numbers like square root of 2, 3, etc. And with circles, we have pi where the digits beyond the decimals were neither ending nor repeating. These numbers are known as irrational numbers. Finally, to complete the number system while dealing with square root of negative numbers, we have the imaginary number I, which is square root of minus 1, which makes it to complex numbers. Interestingly, negative numbers and square root of negative numbers were always elusive to many mathematicians till 18th century. This include Euler as well, who clearly was not ready to accept the fact of I. Later, only to have the most beautiful equation e power pi I plus 1 equals 0, which is the most popular Euler's equation till date. Well, though the name imaginary number sounds scary or unimaginable, but without accepting the fact of square root of minus 1, today it will be impossible to think of alternating current, sound waves, electromagnetic waves, Wi-Fi packets, global positioning system, and so on. This leads to the solution of 3 questions we had at the beginning of this video. Square root of minus 49 equals plus or minus 7i. X squared plus 16 equals 0 has the solution of plus or minus 4i. And the last one is the popular problem was solved by Cardan with the solution 5 plus square root of minus 15, and 5 square root minus 15. But he discarded, saying that these numbers are useless. Now raises the question, with so many mathematicians not accepting the concept of imaginary number, how is it useful in today's applications? Well, let us discuss that in the next video.